Hey my dear students, you are welcome to this very class. In this lesson, we are going to look at electrolysis. We are going to discuss everything about electrolysis, electrochemical series, factors affecting the discharge of ions. We use Arrhenius theory to explain ionic theory under electrolysis. Before we proceed, I am Mr. Mbah, your chemistry teacher from Rosa Mystica High School, Agulu. Previously in our last lesson, we discussed oxidation-reduction reaction, which we call redox reaction. We explained oxidation-reduction reaction as a type of reaction that involves electron transfer. We further explained that oxidation involves loss of electron, while reduction involves gain of electron. In terms of oxidation number, we explained that oxidation involves an increase in the oxidation number, while reduction involves decrease in the oxidation number. So in our today's lesson, we are going to look at how this oxidation and reduction occurs at individual electrodes during electrolysis. Okay, in the specific objective, it is expected that by the end of the lesson, we should be able to explain the order of discharge of ions in the electrochemical series, define electrolysis, explain the technologies used in the electrolysis such as electrode and electrolyte, draw an electrolytic cell, list at least 2 factors that affect the discharge of the ions. Finally, explain the mechanism of electrolysis using acidified water. Okay, now let's begin with electrochemical series. Okay, so let's start with electrochemical series. Now, what is electrochemical series? Electrochemical series is used to identify the position of the ions and their order of discharge during electrolysis. I repeat, the electrochemical series is used to identify the positions of the ions and the order of discharge at individual electrodes during electrolysis. Now, in the electrochemical series, we have the positive ions and the negative ions. Okay, now we go over to the positive ions. In the positive ions, I have a mnemonic which enables me to remember these ions easily and their individual positions. And my mnemonic is, I say, please, sir, call me Augustine Z is leader here, copper makes silver gold. Okay, so this is my mnemonic, and each of the words in this mnemonic represents an ion. The first one is the please, which represents potassium ion. The cell represents sodium ion. The core represents calcium ion. Me represents magnesium ion. Augustine represents aluminum ion. Zinc represents zinc ion. East represents iron 2 ion. Leader represents lead 2 ion. Here represents hydrogen. This one represents copper 2 ion. Next represents mercury ion, the silver ion, and gold. Okay, so these are the positive ions, and these ions are arranged in the order of decrease in order of decrease in electropositivity. So these ions are arranged in the order of decrease in electropositivity, and the ions which are lower in the electrochemical series will be discharged at individual electrodes. I mean, they will be preferentially discharged in the electrode during electrolysis. Then we go over to negative ions. We have the sulfate ions, the nitrate ion, the chloride ion, the bromide ion, the iodide ion, and the hydroxyl ion. And this is arranged based on decrease in electronegativity. Okay, so the ions that are lower in the electrochemical series will be preferentially discharged as the electrode during electrochemical series. Okay, so this is all about electrochemical series. We are going over to electrolysis. Now, what is electrolysis? We begin by defining electrolysis. The electrolysis is the chemical decomposition of electrolytes when there is passage of current. I repeat, electrolysis can be simply defined as the chemical decomposition of the electrolytes when there is passage of what? Current. Now we have some terms that are used in the electrolysis. We have the electrode, we have the electrolyte. Now what is the meaning of these things? The electrolyte first. The electrolytes, these are compounds, either a molten or aqueous solution that conducts electricity and decomposes at the process. I repeat, electrolytes are compounds, either a molten or aqueous solution, conducts electricity and decomposes at the process. Now we have some compounds that are used as electrolytes. There are compounds like the dilute acids, like the tetrahydrosulfuric acid, the hydrochloric acid, and the rest of them. Then we have dilute salts like the aqueous sodium chloride, the copper sulfate. These compounds are used as electrolyte because they can ionize in aqueous solution to produce free mobile ions which conduct electricity, and we normally call them ionic compounds. Then some other compounds which are not used as electrolytes, we call them covalent compounds. Those compounds, when they ionize, they cannot produce free mobile ions which conduct electricity. Some compounds like glucose, the products of petroleum like benzene and the rest of them. These compounds are covalent compounds and they cannot be used as electrolytes. Then we have the electrode. What is the meaning of this electrode? The electrodes are poles or plates through which electron or current enters into the electrolyte or leaves the electrolyte. I repeat, the electrodes are poles or plates through which current enters into the electrolyte or leaves the electrolyte. In the electrodes, we have the anode and we have the what? The cathode. Now, what is an anode? An anode, or otherwise called the positive electrode, allows the passage of current into the electrolyte, or it permits electron to leave the electrolyte. Then we have the cathode. The cathode, or otherwise called the negative electrode, allows electron to go into the electrolyte, or current to leave the what? Electrolyte. Then we have the electrolytic cell. We look at the diagram of electrolytic cell. We look at electrolytic cell. We look at the diagram of electrolytic cell. We have the individual electrodes. We call this the anode. We call this the cathode. Then we have the electrolyte. This is the electrolyte. You can have example like sodium chloride aqueous. You can use it as an electrolyte. Then we have all this. We have the battery. We have the switch. Then we can have ammeter here. We also have the flow of electron. Okay, so this is diagram of electrolytic cell. Now, what is the work of this electrolytic cell? It is in this electrolytic cell that the mechanism of electrolysis takes place. The electrolytic cell comprises of two electrodes, the anode and the cathode, dipped into the electrolyte. We have the battery, and the positive terminal of the battery is connected to the positive anode or positive electrode. Then the negative terminal of the battery is connected to the negative electrode, which is called the cathode. Now, the electron flows through the cathode and goes into the what? Electrolyte. Now, when there is this flow of electron from the cathode into the electrolyte, this leads to what? Electron excess. Excess of electron. The cathode will be highly electronegative, leading to electron excess or electron rich or surplus. Then, while the anode itself becomes electron deficient. Okay, so this is all about electrolytic what? Cell. Now let's go back to electrolysis. Let's look at the explanation of what? Electrolysis. Now, in the electrolysis, I made mention of molten electrolytes, and aqueous what? Electrolytes. Some students or some people are confused with these two words. The molten electrolyte and aqueous. I want to tell you that these two words are not the same thing. They are different altogether. When we talk of molten electrolyte, we think of the electrolyte that doesn't contain water as its solvent. The molten electrolytes are those electrolytes that doesn't contain water as its solvent. Rather, they produce their free ion as a result of what? Heating. Let's say, for instance, we have sodium, molten sodium chloride, this molten sodium chloride does not contain water as its solvent. Now, how it produces its free ion is by what? Heating. When you heat this compound, you will now have sodium ion and chloride what? Ions. Now, these ions will now conduct electricity during electrolysis. Now, let's further look at the reactions that occur at the cathode and what? Anode. We say as cathode. Though I have not explained the factors affecting the type of ions, but with the knowledge of the electrochemical series, we can be able to explain this. Now, during electrolysis of this molten sodium chloride, at the cathode, which is the negative charged electrode, the sodium ion migrates to the what? To the cathode. Why? When it migrates to the cathode, due to excess of electron at the cathode, it gains electron and be deposited as sodium metal. So, in relation to molten sodium chloride, the sodium ion is deposited as what? Sodium what? Metal at the what? Cathode. Then, at anode. At anode, since we have sodium ion and chloride ion only in the solution, the chloride ion migrates to the what? To the anode, where it loses electron to be deposited as chlorine gas. Now you should remember that chlorine cannot exist as a monoatom, or it is not monoatomic. For it to be deposited at the anode, it has to occur as a what? As a molecule, meaning diatomic. That means another atom of chlorine will still combine to produce chlorine what? Gas. And when this happens, you can see that the overall reaction is two molecules of, or two atoms of chloride ion producing chlorine gas plus loss of two what? Electrons. So here, in the case of molten sodium chloride, at the cathode, sodium metal is deposited. At the anode, chlorine gas is what? Deposited. Now let's go over to the case of aqueous electrolyte. Now when we have aqueous sodium chloride, I say aqueous sodium chloride. In this type of electrolyte, it contains water as its what? Solvent. The aqueous electrolyte contains water as its what? Solvent. The mobile ions are produced as a result of what? Addition of what? Water. As a result of addition of what? Water. So when water is added, it leads to breaking of this compound into sodium ion, chloride ion, the hydrogen ion from the water molecule plus the hydroxyl what? Ion. So in the solution of aqueous sodium chloride, you don't have sodium and chloride ion only. Rather, you have sodium ion, hydrogen ion, the chloride ion, and the hydroxyl what? Ion. But when you look at the molten sodium chloride, you have only sodium ion and chloride what? Ion. But in the aqueous, you have sodium ion, chloride ion, hydrogen ion, and hydroxyl what? Ion. So the ions present in the solution includes sodium ion, chloride ion, hydrogen ion, and hydroxyl what? Ion. Now, during electrolysis, the positive ions migrate to the what? Cathode. These two ions, we can say at cathode, the ions present include sodium ion and hydrogen ion. Now we have sodium ion and hydrogen ion. Then which of these ion will be preferentially discharged at the what? At the cathode. You can say the half cell reaction. The half cell reaction. Now, between sodium ion and hydrogen ion, which of them will be deposited or be preferentially discharged at the what? Cathode. So we go back to our electrochemical series. When you look at the electrochemical series, you can easily observe that hydrogen ion is lower than what? Sodium ion. And if you recall, we said that the ions that are lower in the electrochemical series will be preferentially what? Discharged. So the hydrogen ion will be discharged at the what? At the cathode, because it is lower in the electrochemical what? Series. So the hydrogen ion, you can still recall, we said it gains electron at the cathode to be deposited as hydrogen gas. Hydrogen exists as a gas, therefore it has to be diatomic. So you balance the equation. So this is the half cell reaction that occurs at the cathode. Then at the anode, what happens at the anode? We have the ions present. The ions present include the chloride ion and the hydroxyl ion. So, which of these ions will be preferentially discharged at the what? At the anode. So we go over to the electrochemical series. We look at the positions of the two ions. You can observe that the hydroxyl ion is lower in the chemical series than the chloride what? Ion. Therefore, the hydroxyl ion will be preferentially discharged. So the half cell reaction is the hydroxyl ion loses an electron and it is aqueous. Now, you remember that the hydroxide cannot just exist like this. So what happens is that it combines with another hydroxide to produce water and oxygen. And remember, oxygen cannot just exist as a monoatom. It exists as diatomic because it is a gas. So the oxygen combines with another oxygen to produce oxygen gas. Now, the overall reaction in the overall reaction, we have hydroxyl ion, we have water, and we have oxygen gas. So what happens is that we have 4 molecules of hydroxyl ion that produces 2 molecules of water plus oxygen gas then plus 4 electrons. So we have the hydroxyl ion that produces water and oxygen what? Gas. So the overall reaction that happens at the anode is 4 molecules of water producing 2 molecules of water, 1 molecule of oxygen gas, then plus 4 electrons. Okay, so when you compare the two reactions, you can easily observe that the difference is this. This one does not contain water as its solvent, but this one contains water as its solvent. Then the mobile ions that are produced in this one is as a result of what? Heating. While this one is as a result of addition of what? Water. Then the ions present in this one include only the sodium ion and the chloride ion. But in this one you have the sodium ion, the hydrogen ion, the chloride ion, and the hydroxyl what? Ion. And at the cathode, the sodium metal is what? Deposited. But at the cathode of this one, we have hydrogen gas deposited. Then at the anode, we have chlorine gas deposited. But in this particular one, we have at the anode, we have oxygen what deposited. So these two things are different things altogether. Okay, now let's go over to explanation of what Arrhenius theory. First, we look at ionic theory. In the ionic theory, we are going to use Arrhenius theory to explain it. We say Arrhenius theory. Arrhenius theory. Now this is Arrhenius theory explaining what? Electrolysis. Arrhenius theory explaining what? Electrolysis. Now, what is the meaning of this theory? Arrhenius proposed that electrolyte dissolves in water to produce what? Positive and negative what? Ions. Electrolyte dissolves in water to produce positive and negative what? Ions. Then, during electrolysis, or when there is passage of what? Current, the positive ions migrate to what? To the cathode, while the negative ions migrate to the what? Anode. Then, finally at the cathode, the positive ions gains what? Electron, due to what? Excess of electron at the what? At the cathode, while the negative ions loses electron due to what? Deficient of what? Electron at the what? Anode. And this is what Arrhenius proposed about what? Electrolysis. And that is exactly how the mechanism of electrolysis occurs. Okay, so let's go over to factors. The factors. Okay. So let's look at factors affecting the charge of what? Ions. Factors affecting the charge of what? Ions. Now, the first factor that affects the charge of the ion is what? The position of the ion in the electrochemical what? Series. Position of the ion in the electrochemical what? Series. Now, what is the meaning of this? You can still recall that when we have the sodium ion and the hydrogen ion at the what? At the cathode, we said that the ion that is lower in the electrochemical series is preferentially what? Discharged. And that means position of the ion simply represents that the ions that are lower in the electrochemical series will be preferentially what? Discharged. Then the second one is the concentration of the what? Electrolyte. Now, what is the meaning of this? Supposing we are not using aqueous sodium chloride, we use corn sodium chloride. What do you think will happen at the what? At the anode. What do you think that will happen at the what? At the anode. You stay at the anode. At the anode, because of the compound is what? Concentrated. Instead of depositing hydroxyl ion migrating to the cathode, to the anode, to produce oxygen what? Gas. The chlorine, the chloride ion will migrate to the what? Anode. So instead of hydroxyl ion migrating to the what? Anode, the chloride ion will migrate to the what? Anode, because it is more what? Concentrated. So when the chloride ion migrates to the what? Anode, it leads to what? Electron loss. Okay, so chlorine gas will be deposited at the what? Anode, instead of what? Oxygen. And this is the effect of what? Concentration. And you can easily observe that concentration only affects the anode electrode. It only affects the anode what? Electrode. Then we look at the third factor that affects the discharge of the ions, the nature of the electrode. Now, when you look at that nature of the electrode, you have inert electrode, active electrode, and use of mercury as the what? Cathode. Now, inert electrodes. What are inert electrodes? The inert electrodes are those electrodes that doesn't take part in chemical reaction during what? Electrolysis. That doesn't take part in electrolysis. Now, what are the examples of this inert electrode? We have in the inert electrodes, we talk of graphite, or we call it carbon electrode. Then we talk of the platinum electrode. So these two electrodes are inert electrodes, meaning that they cannot take part in chemical reaction during electrolysis. So the ions present in the electrolyte are the ions that will be deposited at the individual what? Electrodes. But when you are using active electrode, the active electrode like the copper electrode, when you are using copper electrode, this one affects the solution of this what? Salt. Assuming you have copper electrode, and the electrode you are using is what? Copper sulfate. Now, because we have copper as a metal in the electrolyte, it will affect the what? The product that is going to be formed at the what? Anode. It is going to affect the product that is going to form as the anode. Now, the copper that is acting as the anode, the copper anode will dissolve in the what? In the solution. The copper anode will dissolve in the what? Solution. So when you use active electrode like copper, there will be reduction in the volume or size of the what? Anode. Because the anode, which is the copper electrode, will dissolve in the what? In the solution. So that is the effect of what? Active electrodes. They take part in the electrochemical what? Reaction. Then use of mercury as a cathode. Use of mercury as a cathode. Supposing now this one affects the cathode electrode. Supposing we have sodium ion and hydrogen ion that migrate to the what? To the cathode. If mercury is used as a cathode, the ion that will be discharged at the cathode will not be hydrogen ion, as we have with these other ones. It will not be hydrogen what? Ion. Rather, sodium what? Ion. Because if hydrogen is discharged at the cathode ion, there will be in high intensity of what? Heat at the what? At the cathode. It will increase the volume of heat at the what? At the cathode. So what happens is that the sodium ion will be deposited at the cathode. And when it is deposited at the cathode, it leads to a reaction between the sodium ion and the mercury cathode, which leads to formation of what? Sodium amalgam. So reaction between sodium and mercury at the cathode is called sodium amalgam. So the sodium ion will be preferentially discharged at the what? Cathode instead of the hydrogen ion if we are using mercury as what? Cathode. Then we will go over to what? the mechanism of electrolysis using acidified water. Okay, so we look at the mechanism of electrolysis using acidified water or dilute tetraoxosulfaceous acid. Now, what is acidified water? Acidified water is the water that contains few drops of tetraoxosulfaceous acid. And what is the work of these few drops of tetraoxosulfaceous acid in water? It helps to increase the conductivity of the solution by increasing this concentration. Now, the diagram for the experiment is like this. We call it the Hoffman voltameter. The Hoffman voltameter. Okay, now we have the platinum anode and the platinum cathode. Then we have the electrolyte, which is hydrogen ion from tetraoxosulfaceous acid, sulfate ion from tetraoxosulfaceous acid, the hydrogen ion from water, and hydrogen ion from water as well. Now we are going to look at the two products formed at the anode and cathode. So we go over to the cathode. The ion present in the cathode is hydrogen ion only, because that is the only positive ion we have here. Now, the half-cell reaction is that the hydrogen ion migrates to the cathode. Due to excess of electron in the cathode, it gains electron to be deposited as hydrogen gas. Then, when you look at this reaction, you can determine its oxidation number at the reactant side and at the product side. So before the reaction, hydrogen ion is +1. It has +1 valence. But after the reaction, the valence reduces to 0. So we can easily conclude that at the cathode, reduction does occur. So at the cathode, we have how many volumes of hydrogen? So at the cathode, we have 1 volume. Though we still do something after the reaction to confirm if it is actually 1 volume or 2 volumes. But what happens is that hydrogen gas is deposited at the cathode. Then at the anode, we have the sulfate ion and hydroxyl ion. So when we go back to the chemical series, we can easily observe that the hydroxyl ion is lower in the electrochemical series. So it will be preferential discharge. Then the half-cell reaction is 4 molecules of hydroxyl ion leading to production of 2 molecules of water plus oxygen, then plus 4 electrons. So this is the overall reaction that occurs at the anode. Then we can compare what happened at the cathode with what happened at the anode. Now let's look at the number of electrons at both. Now the overall reaction is 2 electrons at the at the cathode. But at the anode we have 4 electrons. And therefore before we produce overall reaction at both electrodes, we have to balance the number of electrons in the reactant side with the one at the product side. So what do we do? We can multiply this equation in the anode by 2. We multiply it by 2. So when you multiply it by 2, we have 4 hydrogen ions plus 4 electrons producing 2 volumes of hydrogen gas. So we can easily conclude that this is not 1 volume, but what? 2 volumes of what? Hydrogen gas produced at the what? At the cathode. So then in this other one we have 4 molecules of hydroxyl ion producing 2 molecules of water. This is aqueous. This is aqueous. Then plus 1 volume of oxygen plus what? 4 electrons. So at the anode compartment we have 1 volume of oxygen gas produced. Okay, so we cancel out the number of electrons in the reactant side and that at the product side because they have the same number of what? Molecules. So 4 molecules of electron at the reactant side and 4 molecules of electron at the product side. So you combine the equation. Hydrogen ion plus hydroxyl ion will give you 4 molecules of what? Water. Producing 2 molecules of water plus oxygen gas plus hydrogen gas. Okay, so this is the overall reaction. 4 molecules of water producing 2 molecules of water plus 1 molecule of oxygen gas, then plus 2 molecules of hydrogen gas. So this is the overall reaction at both what? Electrodes. Then again, there's something you need to know. When you look at electrolyte, we have hydrogen ion, sulfate ion, hydrogen ion, and hydroxyl ion. Now, when you go back to this reaction, you can easily observe that the hydroxyl ion has been removed from the electrolyte, the hydrogen ion has been removed from the electrolyte, which means water has been removed from the electrolyte. So what you have in the electrolyte is hydrogen ion and sulfate what? Ion. So what you have to say about the concentration of the solution after what? Electrolysis. Because we have hydrogen ion and sulfate ion in the electrolyte, which is in the solution, they combine to produce what? Tetraoxosulfate what? Acid. So the result of the solution is that the solution becomes more acidic. So after electrolysis, when water has been removed, the solution that remains is tetraoxosulfate acid. It becomes more what? Acidic and is highly what? Concentrated. Okay, so we have in this lesson we have gone through electrochemical series. We have looked at the definition of electrolysis, electrodes, electrolytes, factors affecting the nature of ions, the Arrhenius theory, use of acidified water to explain electrolysis. Then we are going to look at some questions. Let's just pretend ourselves some questions. Okay, so looking at the evaluation, we have the first question. The common feature of reactions at the anode is electrons are consumed. But you remember that in the anode we talk of electron deficiency. So electrons are not consumed. It's not correct. So B, we say ions are reduced. You look at this. When you look at the cathode, you calculate the valency. Before reaction, this is +1, and after the reaction, which is what? 0. So reduction occur at the what? Cathode. Therefore, we say ions are reduced. No. At the anode, reduction does not what? Take place. So we say oxidation in C, oxidation is involved. So when we go over to the reaction that occur at the anode, we have hydroxyl ion before the reaction, bearing oxidation number of -1, and after the reaction, producing hydroxide, which has oxidation number of what? 0. So when you compare these two oxidation numbers, you can observe there is an increase from negative to what? Positive. So oxidation is what? Involved. because in oxidation we talk about an increase in oxidation what? Number. Then let's look at the final answer we have. We say that the electrode dissolves. Though electrodes can dissolve at the anode, but it's only when you are using a metal of its what? Salt. So the common feature there is that oxidation is what? Involved. Then the second one, which of the following substances is a non-electrolyte? We say that non-electrolytes are those ones that cannot produce free what? Ions when they ionize. So when you look at the tetralose of a 6, when it ionizes, we say, one, when this compound ionizes, you have 2 hydrogen ions plus sulfate ion. So it produces free mobile ions, therefore it can conduct electricity. It's an electrolyte. Then the second one is the ethanoic acid. So when this one hydrolyzes or ionizes, it produces these 2 ions, the ethanoic acid ion and the hydrogen ion. So it conducts electricity. Then finally, when you look at the C, the third one, which is what? The glucose. C6H12O what? 6. So this compound is an organic compound. This compound cannot produce free mobile what? Ion. Therefore, it is a non-electrolyte. Then the final one is the ammonium chloride. When it ionizes, it produces ammonium ion plus chloride ion. So the 1, 2, and 4 contain free mobile what? Ions. Therefore, they are electrolyte. But the third one is a non-what? Electrolyte. So the answer is what? C. Then the final one is what happens at the cathode during electrolysis. So during electrolysis, what happens? Anion is oxidized. But let me ask you, what is an anion? When you talk of anion, we talk of those ions that migrate to the what? Anode. The ions that migrate to the anode are called anions, meaning anode ions. Like in acidified water, you have hydrogen ion. So this is an anion, because this is anode what? Ion. Then those ones that migrate to the cathode are called the cation, meaning cathode what? Ion. So we say anion is oxidized. No, we don't talk of anion at the what? At the cathode. Then the anions loses electrons. We are speaking of anions. Anions are not involved in what? Cathode. Then C, cation is what? Oxidized. So let's look at the oxidation number. It's from close to what? 0. So cations are not oxidized, but what? Reduced. Then cation is discharged. Fine. Because these ions are discharged at the what? Cathode. The one that is lower, the chemical state is discharged at the what? Cathode. So, and it's a cation. So the cation is discharged at the what? Cathode. So the answer becomes what? G. So, having gone through this, I believe that you actually understand everything I said in the lesson. Though I gave an assignment, you can still go to the assignment, and if you are encountering any difficulty, you can as well contact me via my WhatsApp number 081 3838 7567. I repeat 081 3838 7567. Thank you for your audience, and may God bless us all.
Rosa Mystica High School, Agulu.